this division style exponent problem. The first thing I'm going to do is use the reciprocal. So I'm going to circle that one. That one's the only one that has a negative exponent. So that's the only one I'm going to have to move. The top has the 2x y cubed from the original problem, but then now it's also going to have the x cubed that I'm going to fix with the reciprocal. So the first thing I'm going to do is take this and move it up for its reciprocal. That fixes the negative. And then 2y squared is left on the bottom. Okay, now I like to write these out. You guys don't have to, but you can. Anybody thinks that they perhaps did not silence their phone, if they could come over here and check it, please. Is it you? Okay, so I wrote out the top and I wrote out the bottom. Now I'm going to see giant ones. I see a giant one made of 2's, a giant one made of y's, another giant one made of y's. And now I have 4 x's left, so x to the 4th and 1 y left. And nothing is left on the bottom. I crossed it all out. Okay, scientific notation problems. Let's go over this again. So this is division. So I'm going to do 7.1 divided by 2.7. I'm going to divide the front numbers and then subtract the exponents. Be very careful. It's not 6 minus 3. It's 6 minus negative 3. Be really careful about that. Okay. So now I'm going to do 7.1 divided by 2.7. And I'm just going to round that to 2.6. Okay, big question of the day. What's 6 minus negative 3? 9. Beautiful. Remember, 2 little minuses next to each other make plus. Okay, now last question for this problem. Is it in scientific notation, proper scientific notation? Yes, it is. Why? Because the number in front is between 1 and 9.9 repeated. Close enough. You guys are in there. You just want to make sure there's one number in front of the decimal. Okay, pretty much everything we're doing today is in the packet. So if you guys could find the page that says 2.1.3 resource page. And then get a colored pencil out. You just need one colored pencil today. Okay, so we are going to find the slope of all of these lines. So we're going to find the slope of A, slope of B, the slope of C, and the slope of D. This diagram is pretty complicated. You guys see where I got the names of the lines from? So there's capital A, capital B is this one, capital C is that one, and capital D is that one. The hardest thing about this diagram is piecing it apart because they have them all overlapping. Okay, so we're gonna start with the slope of A. Take your colored pencil, and these little guys right here, they have dashed them in for you, are slope triangles. Okay, what we learned yesterday is slope is rise over run. So I'm going to take one of the little triangles and see how many boxes it goes up. I just wrote a 1 there because it goes up 1 box. So the rise is 1 and it goes over 1 box. Okay, so the slope of A, and we write the word M for slope. M equals the rise is 1 box. The run is 1 box. Do you guys need me to explain what the rise and run are again? Yeah. Okay. The rise is how many boxes high this triangle is, and it's 1 box high. And the run is how many boxes is the base of this triangle, which is 1. Rise is up and down, run is left and right. So height, base. Okay, now what is 1 divided by 1? 1. So the slope is 1. Okay, what that means is this line goes up 1 box for every box it goes over. And that's probably the easiest one because they're ones. Okay, so let's look at B and color in those, and then maybe you'll be able to see the difference after doing B. Okay, I'm gonna like not label this box right, or this triangle right here because it's right next to the 5 and I think that's confusing. Let's zoom in. How many boxes high is this triangle? 3. How many boxes wide is this triangle? 1. Okay. So that means the slope is 3 over 1. Rise over run, which is 3. Okay, you're starting to see where the numbers are coming from? Okay, now let's do C. Perfect. So just pick any triangle you like. The height of the triangle is 1. The base of it is 2. The height is 1. The base is 2. So the slope is rise over run 1 over 2. Do not convert that to a decimal. Don't convert that to a decimal. No decimals. No decimals for slope. No decimals for slope ever. Why? Because you're just counting the number of boxes. If you made it a decimal, you'd make it much harder. It's really hard to find 0.5 of a box. It's super hard. to find like 0.67 of a box. But going up 2/3, we can all do. So never decimals for this. Okay, last one. This one's special though. I want you guys to think about this one. This is my favorite. This one has a very special thing happening to it that's different from the other three. Beautiful. Okay, so first, the height of the triangle is 2. So the rise is 2. 1, 2, 3, 4, 5. Raymond got that. Okay, so you have to say the slope is 2/5, but then you have to have that little thought to yourself. This one's going downhill, so it's negative. Mrs. Barbara Jones used to work here. She taught me this super cool trick about how to find out if it's positive or negative. Everyone take your hand and make the L for loser sign. So take your left hand and make L. Okay. Put your hand over the graph like this. Okay, now which one has arrows pointing up and which one has arrow pointing down? Positive, 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 negative. She's a genius. I never would have thought of that. I could go to my grave and never have thought of that before, but I always learn stuff from other teachers, which is really cool. Okay. Any questions about number 23? Number 23, anything? You sure? Okay, move down to number 24. It's weird because I put 24 over here and 25 here, but that's okay. So they're sort of like, you guys ever like not want to jump into a super cold pool? I do. Some of you might want to jump into a super cold pool, but if you don't want to jump into a super cold pool, what can you do instead? Yeah, go in little by little. I call it the beach entry. Like you just go in a little bit, then you get used to it. You go a little bit and get used to it. Okay, that's what these problems are trying to do for you. So on number 23, they drew the triangles for you. On number 24, they give you the coordinates as little dots of where to draw your triangles. Okay. They also didn't give us nearly enough room, but that's fine. So we're just going to put A, B, C, D, E, and we're just going to have to write kind of small, but that's okay. Okay. So what I want you to do is I want you to find line A, and I want you to find 2 of the coordinates and then make your slope triangle. So you see how they have a coordinate here and a coordinate here? Go straight down and straight over to make your slope triangle. Now here's my question. Does it matter which 2 coordinates I choose? No, because the height and the base are going to be the same no matter which ones you choose. Okay, so the height is 2. The base is 1. So we say m equals 2/1, which is 2. And then I have to go to myself, okay, increasing or decreasing? Increasing, right. So I leave it positive 2. There's actually only one line up there that's decreasing. Can you tell which one? It's hard to tell which one is labeled. This one is D. That one is C. This one is D. Okay, anyway. Okay, now find line B. Find 2 coordinates that you like. And color in your slope triangle. Okay. Raymond has it, I can hear it. Height of 3, base of 2. Height of 3, base of 2. Slope is 3/2. You just leave it like that. This is not reducible. It's not over 1. You just drop the mic and walk away. That's it. 3/2. Done. Okay, now what about C? Is it just the opposite? You guys can pick any 2 coordinates. You don't have to pick the same ones as me. I'm just trying not to make my triangles overlap so it's pretty. I think I'm gonna have to go get some zinc after being in this class. You guys are freaking me out. Okay, height of 2, base of 3. Still going uphill though. Okay, what is the academic vocabulary word for 3/2 and 2/3? We just used it in the exponent problem. Yeah, right? Okay, you're not wrong, but I mean the relationship between 3/2 and 2/3. What do those 2 things have in common? What are they? We just did it in the exponent. Reciprocals is what I'm looking for. Those 2 are reciprocals of each other. It means that they're flipped. You can say reciprocal in your head, it helps. Okay, D. I'm gonna try to go up here so that my slope triangles don't overlap. Yes, this one's decreasing. Excellent. Great job. So 1 on the height, 1, 2, 3, 4, 5 on the base. Decreasing, so we have to have that little moment where we say it's negative and then rise over run. Remember, always height over base. Listening. It does not. You can draw it wherever you like. You'll get the same exact answer just as long as you remember the height, that the base will be on the top. And it's really weird because we use the word base and then it's the top. But as long as you understand that that's the left and right. Yes, you may. Yes, you may. Okay, last one for this. E is very interesting. E is flat. Okay, what is the change in height when there's no change at all? Zero. Okay, all horizontal lines have a slope of 0. And we'll talk about vertical later. But all horizontal lines have a slope of 0. I like to say that people like me who are in our older generations, we like to go to the mall to walk because it has a slope of 0, meaning that there's no hills of any type. I like to walk where it's flat because, you know, lazy. And it's air conditioned. And there's fun food to purchase. But anyway, I mostly think that we go there because the slope is 0. I prefer my hikes to have a slope of 0. Okay, moving on to number 25. So we're taking one more step into the pool. This one does not have any coordinates. So you have to actually find them. So come over here and write A, B, C, D. And what you want to find is called a lattice point. Have you heard those words before? Anybody heard the word lattice point? Lattice point means a nice whole number coordinate where it crosses perfectly on the corner, on the pieces of the graph paper. Do you know what I mean by that? So you want to find a spot where it crosses perfectly. So let's start with A. So for example, this spot right here is a lattice point. It's a lattice point because it crosses perfectly on the corners of the graph paper. And then you want to find another lattice point. It doesn't matter how far down you go, just find two lattice points and then use those to make your triangle. You see how they're increasing the difficulty level each time. So this one has a height of 1 and a base of 2. And what else? Yes, negative 1/2. Okay, B. This is line B. Find a lattice point. I'm going to choose this one and this one. You guys can choose any two that you like. It doesn't have to be those two. Okay. Color in your slope triangle. Height is 2. Base is 1. This one's negative, actually. If I do the trick and cover up the left side of it, I can tell the arrow's going down. So this one actually is negative 2/1, and we write the final answer as just negative 2. C is positive, also harder to find lattice points on. Height is 2. Base is 3. Going uphill. And what is D? Beautiful. We don't even have to do any work. There's not even any work to show. It's just 0. Alrighty, guys. So last one we're going to do is number 26. I need to get the book problem for you, so just hang on a second. Oh, also, I really like my joke for today. I want to make sure that I show it to you. But it might not make sense if you're not a Lord of the Rings fan. Has anyone watched it at all? Lord of the Rings. It's old. But it might, I don't know. I think it's funny. Okay, so here's what we're doing today, 23 to 26B. We've already done 23 through 25. We just have to do 26A and B. The homework tonight is 30 through 34. And the super scary ghost guy said, "Who enters my domain?" And then he said, "All real numbers." Because that's the domain. I don't know. I think it's good enough to watch them. They're 3.5 hours long each. Yeah, they're good though. Okay, anyway, let's go to 26. Okay, on number 26, they want us to draw slope triangles. We're going to do the first two. A line that goes up 3 each time it goes over 5. Okay, so our job in number 26 is to draw a slope triangle. Hold on. To draw a slope triangle that goes up 3 every time it goes over 5. Also, when I'm first, Holly is first. Okay, and I'm almost done. So up 3 over 5. Here's the thing they don't tell you. They don't tell you where to start. You got to pick a point. Just pick anywhere. Anything you like. I'm just pick here. Try to pick something other than what I picked. Otherwise, you're cheating. No, I'm kidding. Okay, now draw a triangle, slope triangle that is up 3 over 5. So up 3 over 5. How are we feeling about slope triangles? So easy, you'd like to be done. Okay, last one. A line with the change of x is 4 and the change in y is -6. Okay, so change in x is 4. Change in y is -6. Okay, I highly suggest on this one that we start up top. I can tell because it's going to go down 6 from wherever I start. So just start anywhere. Try to start up here-ish. You can start any of these. Okay, change in x is 4, so you're going to go over 4. And change in y is -6. 1, 2, 3, 4, 5, 6. Why? What? You mean like you didn't have to start here. You did not have to start there. You could start anywhere, just as long as you go over 4, down 6. I just started up there because I could tell I was going to go down 6, so I wanted to make sure I had enough room. Okay, so 6, 4. Okay, we have to do a little bit of work here, actually. So first, I noticed it's going downhill. You could tell because we went down 6. The height is 6. The base is 4. But we leave these in reduced fractions. How do I reduce -6 fourths? So divide by 2. Divide by 2. -3 over 2.